Hello students, how are you doing today? In the last part we discussed about equilibrium, and that part was regarding definition of equilibrium and the types of equilibrium. And in today's lesson we are going to talk about conditions of equilibrium. So before we move ahead, let's talk about torque. What is torque? Torque is a turning effect of a force. It's a turning effect of a force, and it is denoted by symbol tau, and tau is written F into L. So we can write torque is equal to force multiplied by moment arm. You can write like this: torque is equal to force FL sine theta. This theta is the angle between force and moment arm. So, what is torque? Torque is the turning effect of a force. Like this is a nut, and you want to tighten this nut or like loosen this nut using some spanner, right? Using some spanner. This is your spanner. And this is your nut, right? And this is the point around which the movement will take place. You can say this is the pivot, or you can say this is the axis of rotation, right? The axis of rotation will be passing from this point, because rotation is like this, about this line. So this is the axis of rotation. So torque is always around some point, right? So this is the point where around which the torque takes place, and we are applying force like this. So this is called line of action of force. This is line of action of force like this, and this distance between force, line of action of force, and the axis of rotation is called moment arm. Force is here, here is the moment arm. So if you just multiply both of them, you'll get torque. Torque is the vector product of force and moment arm. FL sine of theta. What is this theta? This is the theta. If this theta is 90 degree, the torque will be maximum, because you know that sine 90 is 1. So torque is equal to FL sine of 90 degree is FL. This is 1. So FL, that is maximum, right? This is maximum torque. So you will get maximum torque when this theta is 90 degree between line of action of force and axis of rotation. So this angle is between F and L, between the force, line of action of force, and the moment arm. So torque is the turning effect of a force. So you are applying force, and turning effect is created in the nut. So this turning effect is called torque. So let's move to the next example. So let's take an example of seesaw game. What happens in the seesaw? There's one plank over here over the pivot. This is a pivot and this is a uniform plank. So it can move. This is a point around which the torque is produced, right? So if some child is sitting over here, suppose here, some child is sitting over here, so its weight is acting downwards. That is W1. And the distance between the pivot and the child will be moment arm, right? Because this is the point around which the torque is producing, and here is the force. This is a line of action of force, and this is the moment arm. So what is this? The product of these two would be called torque. So this is the torque 1. Torque 1 would be W1 into R1. This is R1. Suppose the second child is sitting over here and his weight is W2 and the distance from the pivot is R2. So what will the torque do? W2, force into R2. So what is the condition of equilibrium? There are two conditions of equilibrium. Number one, sum of all the forces acting on an object is 0. Vector sum, right? And the second condition is vector sum of all the torque acting on a body about an axis is 0. So in this case, there is no force that is acting right or left. So this condition has two parts. Sum of Fx is equal to 0 and sum of Fy is equal to 0. So this is not being used here because there is no force acting on right or left. But sum of Fy is equal to 0 we can use here because one force is upward, right? Here the pivot is basically supporting this plank, so this is applying basically upward force to balance these two downward force. So you can say that this force, the pivot force Fp, is equal to W1 plus W2. This is basically sum of Fy is equal to 0. Sum of all the downward forces equal to sum of all the upward forces. So this is called first condition. This is a part of first condition. Okay, so this is being used here. Okay, let's move to the second condition. Sum of all the torque is equal to 0. What does it mean? That means that sum of all the clockwise torques is equal to sum of all anti-clockwise torques. And this force, this is balanced over here, and this force is basically like this. When child A sits over here, so he is basically applying force here. So the marker is moving right side. This is clockwise torque, and when the child B sits over here, so basically he is producing anti-clockwise torque. So according to this condition, both these torques must be equal. Or in other words, you can say sum of all the torque must be equal to the 0 about an axis. So you can say torque 1, sum of the torque clockwise is equal to sum of all the torque anti-clockwise, right? So this is a clockwise. So this T1 will be here. Torque 1 is equal to torque 2. So using this equation, we can write over here that what is torque 1? Torque 1 is W1 into R1. What is torque 2? W2 into R2. Right? So this is very simple. This is the first condition. This is the second condition. What is first condition? It has two parts. Sum of all the forces along x-axis is 0. What is this? Sum of all the forces along y-axis, along vertical axis is 0. Alright, but in this case there is no force either on the right side or on the left side, so this is basically, this is not being used over here. So sum of Fy, we are using this one because we have upward forces and we have two downward forces. Okay, so this is the second condition, sum of all the torque is equal to 0. Or in other words, you can say algebraic sum of all the clockwise torque is equal to algebraic sum of all anti-clockwise torques. So this is basically first condition and second condition of equilibrium. So I hope you have understood this concept. Thank you very much.
जहालत के सारे अंधेरे न हो हर मुसल